Welcome back, polar bears and polar cubs. Let's talk about binary molecular compounds. So these are going to be compounds that have two nonmetals. So these are going to be compounds. So you know where the stair step is on the periodic table. These on the right-hand side are nonmetals. So it's going to be two of those. Hydrogen is also going to be included in that. So in order to name these, we use the prefixes 1 through 10, which can be found in your book if you want to take a book home, or they will be right here and you should memorize them. So mono, di, tri, tetra, penta, hexa, hepta, octa, and nona, and finally deca. So when you're writing these, the first element, you're going to write the full name and the prefix in front of it. So like, for example, if it were carbon as the full, if it was carbon like that, you would write just carbon. It would be capitalized, but it would just be carbon. Now, notice how it would be a 1, but we do not, no use of mono, meaning we do not use mono on the first element. On the second element, okay, second element, we're going to do the prefix. That's going to be 1 through 10 we're going to use on the second element, whereas on the first element, we're going to use 2 through 10. Then we're going to drop the ending again. So we're going to drop the ending and we're going to change it to I, just like we have in the past. And finally, the third rule is if you have an A or an O at the ending of a prefix, you're going to drop that if it begins with a vowel. So if the element begins with a vowel, you drop A or O. So let's go ahead and let's try some of these. So I is iodine. So you're going to write iodine. 7 is hepta. So we'll write hepta. Bro. And now instead of bromine, it's bromide. Okay, you guys try the next one. 3, 2, and 1. 4 is tetra. Sulfur. 9 is nana. Chloride. And that's how you would take a formula and go to a name. Now, let's do the opposite. So I got the name. Now I got to go formula. So it's dihydrogen. So we know that we have hydrogen. Di means a 2. So we're going to put a 2 next to the hydrogen. Monoxide, which means that we just put a O. Hey, that looks familiar. We know that one as water. So this is its chemical name. This is what we classify as its common name. Okay, go ahead and try the next one yourself. 3, 2, and 1. Phosphorus, meaning that we're just going to put a P. Hexafluoride. Fluoride is F, and hexa is 6. All right. So I want you to go ahead and practice those on the worksheet. We do, however, have some hydrate notes to take. So when it comes to hydrates, what this does is it adds on to the ionic compound. So these were from last week. Okay. So you're going to name that just like we did last week. That's part 1. Part 2 is you're going to use the prefixes that we went over today. And then the word hydrate. So hydrate responding to water. It's going to tell you how many water molecules are there. So I'm going to go ahead and do one of these examples and then have you do the other. So Mg is magnesium. Fluoride. Now we come to the second part. 2 is di. This is capitalized. So it's di hydrate. Okay, go ahead and try the next one on your own. Give you 3, 2, and 1. K is potassium. ClO2 is chlorite. And 6 is hexa. All right, that is taking a hydrate formula and making a hydrate name. Now, on the other way, it's going from formula or the name to the formula. So how do you do it? Well, you write the ionic compound first, then you're going to use the prefix and then follow it by water. And then you'll put a dot in between. Now, why do we put a dot in between? Well, what that dot tells us is that that's how many waters are attached to the compound. So it's an attachment almost. So we put that dot as saying like, hey, this is attached to it. But if we really wanted to, we could get rid of it. So again, I'll do the top one, and then you guys will do the bottom. Aluminum oxide. So aluminum has a +3 charge. Oxide has a -2, giving me Al2O3. Now we're going to have a dot. And then tetra is 4. Hydrate means water. If I told you to hydrate, you'd be chugging some water. All right, let's work on the next one. I'll give you 3, 2, and 1. Barium has a +2 charge. Phosphate has a -3, giving us Ba, parentheses, PO4. This would get a 2. This would get a 3. That's weird. That's a 3. Times, so that attachment, 8 is octa, hydrate. All right, those have been our notes over binary molecular compounds and over hydrates. Go ahead and complete the rest of that worksheet and let me know if you have any questions.